Okay, for what we have in number 2, okay, we have the ratio of x squared plus 84x plus 84 all over x cubed minus 4x. And we have another situation where partial fraction decomposition will be performed. And so, in factoring the denominator, okay, we have x plus 2, and x minus 2 dx. And again, we can go ahead and perform partial fraction decomposition since the degree of the denominator is higher than the numerator. And so, in looking at partial fraction decomposition, okay, we're going to split this ratio up as the sum of 3 distinct fractions with each having a denominator respectively of x plus 2, and x minus 2. And so as we carry out what we have here, again we have for the factored out in the denominator form of the original ratio, okay, we have, and this we have breaking up, we say we have a over x plus b over x plus 2 plus c over x minus 2. And we have distinct zeros. We're going to have 0, negative 2, and positive 2 that we're going to use upon setting up the equation as we clear out the fractions. So in rewriting, we have x squared plus 84x plus 84, and with a over x, x will go out, however it will be multiplied by both x plus 2 and x minus 2, and b with x plus 2 to go out, we're going to have this multiplied by both x and x minus 2, and then we have for c over x minus 2 with the distribution, c is going to be multiplied by both x and x plus 2. Okay. Alright, so we have x squared plus 84x plus 84, and then we have the set of terms that will result, and again we have our distinct zeros, 0, negative 2, and positive 2, which we're going to use in substituting so as to determine the values of the coefficients in the numerator, a, b, and c. And so in looking at, say, the first case, if we set x equal to 0, okay, we have left hand side again is going to be 84, and then we're going to have, upon substitution, we end up with negative 4a, thus the value of a will end up at negative 21. And then for the next 0, okay, we'll let this be x is equal to 2, and so in the follow through on this one, okay, if we set x equal to 2, both a and b will cancel out, and we will be left with 256 is equal to 8 times c, thus the value of c will be at 32. And then for the final 0, we had that x is equal to negative 2, and so this will cancel out the coefficients a and c and leave us with negative 80 is equal to 8b, whereupon b is equal to negative 10. And so now, having arrived to the values of a, b, and c, okay, we can take this set of terms and reestablishing. Okay, we have for a over x, okay, this is going to be equal to negative 21 over x minus 10 over x plus 2 plus 32 all over x minus 2. So with these ratios, we can now set up integration. Okay, and so we have for the integral of the problem, okay, we're looking at the integral of negative 21 over x dx minus the integral of 10 over x plus 2 dx plus 32 all over x minus 2 dx. And there are various ways upon which the answer can be displayed, but I'm just going to leave this as sums and differences of logarithms. And the nice thing about this one is that all of x plus 2, and x minus 2 will have a derivative going to 1, and so we're just going to have 3 basic logarithmic terms. And we have, among our antiderivatives, we have negative 21 times the natural logarithm of x minus 10 times the natural logarithm of x plus 2 plus 32 times the natural logarithm of x minus 2 followed by the constant.